link atıyorsunuz.
Sabit bir ekip var tabii ki. Neden olmasın? Section 1, Section 2, Section 3. There are 3 sections. And that's stable. I mean, it's just fixed. Where are you actually? Which section are you in? You have to register to that section.
Section 1, I think.
Yeah, everybody, and there's you're going to go to assignments on Section 1. Okay, and you're going to yeah, just upload. Everybody is doing that. Why can't you do?
Ben ekipte değilim de hocam, ona katılayım.
Ben de bir şey sorabilir miyim?
Tabii. Okay, go ahead. Batuhan, Batuhan, just a couple of minutes. Ahmed was raising hands for a little bit, so let him talk first, and then after him, you're gonna talk. Okay?
Okay, teacher.
Yeah, go ahead.
I am from this section 3, but I did participate in your section 2 class at 9. You told me just when the time comes, I come and send a message for you to take attendance. So.
Thank you. Yeah, I remember. You can leave whenever you like. Yeah.
So I have to wait a little bit, or I can go?
No, you're fine. Just leave.
Okay. Thank you. Have a good day.
You too. Bye bye. Yeah, Batuhan, go ahead.
Siz bize elemesini diyorum. Sınavın yapacağı linkleri atacak mısınız, yoksa biz MyLab'den nereden gireceğiz? Ben onu bilmiyorum da.
What Batuhan's question is where are we going to take the quiz? Quiz is going to be similar to homework. What you're going to do is you're going to go to MyLab and you're going to see the quiz right away, and you're going to start as if you are doing the homework. It's similar, okay? The difference is you're going to have a couple of hours to finish it, okay? And of course, you are going to be doing it on your own. For the homework, you can talk to a friend and discuss problems, etc. But you're not allowed to discuss. You have to do the quiz on your own. Okay, that's the difference between homework and quiz.
Sorular homework'e yakın olacak değil mi hocam? Homework'lere.
Of course, yeah. Similar to homework questions. That's right. Any other questions? If you don't have any other questions, please write your questions that you want me to solve from MyLab, and I'm going to solve it here for practice for the quiz.
Teacher?
Yes, Halit. Yeah, go ahead.
I am Muhammad. When I am going to solve my homework in the MyLab, I have a problem here. I couldn't open that.
Mohammed Fahmi, did you register for MyLab? Did you pay?
Absolutely, yeah.
And you cannot open what? You cannot open the homework, or you cannot get into MyLab?
I can't open all of homework because I opened before another computer. This is a problem.
No, that's not the thing. No, I don't think that's the case. If you can write your problem explicitly in the email, I'm going to forward it. If I will try to answer that first. If I cannot answer, I'm going to forward it to the publisher's site, and they should solve it. As far as I understood, you cannot see the homework. Is that it?
Yeah, I can see homework when I can only read because you opened at the more than one.
Actually, I'm not sure that you can access from different computers at the same time. I never tried that. Just use one computer then.
Okay, but I am now at another city, so could you solve this problem? I won't log out all of my computer, only my computer.
Okay, Mohammed Fahmi, is it doesn't matter you are in a different city or anything like that. Okay, just
no, I have two computer. My computer at another city.
Okay, but who enters there? Your MyLab. Who uses your MyLab there?
It's closed. My computer is closed. But I didn't log out. I didn't do log out.
Okay, as long as your computer is off, it should be no problem.
I tried to.
Mohammed Fahmi, why don't you write in the email clearly? Okay, if you state your problem clearly, explicitly, then I can send it to them and they can take a look. I mean,
Okay, I'm going to
as
write.
far as the computer is off, it shouldn't be a problem. I don't know.
Okay, after this, then I will.
Yes,
write.
please just send me an email and see if I don't understand your email. I may ask you to just write it maybe more clearly. If not, if it is clear, if I can answer, I will answer. But if I cannot, I'm going to send it to the publisher. They should fix it.
Thank you, lots of teacher.
Thank you, Mohammed.
Teacher,
Yeah, go ahead.
Can we ask our questions from homework?
Yes, of course.
Can I share my screen?
Yes, definitely. You can share or you can write the numbers and I can look at the numbers. And I'm going to open up the, I already opened up the MyLab, so I have it here.
But it's not about numbers. It's there's too many words.
Yeah, okay, go ahead and share. You can share. I think I allowed you to share. You can do that, but let's answer the questions first, Batuhan. Then we are going to start answering your, yeah. Mohammed Khalid, what's the question? Or did you forget to?
Teacher, I was asking about MyLab. Hala kayıt yapamadığım için nasıl sınav alacağım?
Size hala siz bana e-mail attınız mı publisher'a göndermem için? Hani sorunuz neydi tam olarak Muhammed Halit, hatırlatır mısınız?
Ben bir kitap aldım. Onun kullanacağım zannettim. Bugün başka bir kitap öğrendim kullanacağız. O yüzden yani şimdi
size konuşacaktık değil mi? Sizle konuşacaktık. Unuttuk onu. Şöyle yani ne yapabilirsiniz? Yani yapabileceğiniz şu, yeni kitap alabilirsiniz. MyLab Access yapabilirsiniz. Çünkü MyLab faydalı. Mesela
tamam, buradan sıkıntı değil de alacağım ama bir arkadaşlarla sordum. 2 gün falan sonra numara falan gönderecekler.
Halit, size de yapabiliriz. Late registrantların yaptığımız gibi extension verebiliriz. Ama bunun için e-mail atın. E-mail'de söyleyin sorununuzu. Ona göre sizin isminizi not edeyim ben. Size geç vereyim quiz'i.
Tamam.
Tamam? Okay.
Tamam.
Thank you very much, Halit. Muhammed Halit. Okay, so anybody else asking any questions? Go ahead.
Çok pardon, sizi uğraştırıyorum da ben yolladım request'i. Kabul eder misiniz acaba?
Tabii ki.
Çok teşekkür ederim.
Estağfurullah. Sadece sizliği bayağı var zaten. İyi oldu.
Açayım hocam.
Okay, biraz daha var. Açabilirsiniz, evet. Please go ahead and share your screen for us to see your question, Batuhan. Batuhan, can you enlarge it a little bit if you can? Because I can't read it really. By the way, I have a question, guys. When I show MyLab on my screen, can you not read it? Is it like this?
No, I can read it, teacher.
Okay, perfect. Because now I think it's small for me, kind of small, what you're showing me. Let me see if I can do anything to make it bigger. Yeah, it's better if I make it full screen. Let me see. Yeah, I can read it now. Yeah, it's okay. It's okay, I can read it. Yeah, go ahead. What's the question? Yeah, this is about intermediate value theorem. Okay, and what's your question, Batuhan? Or can you hear me, guys?
Yes, we can hear you.
Yes, teacher.
Hocam 10 dakikadır konuşuyorum. Mikrofonu açmamış. Pardon. Gx fx eksi x is gx continues on O to 1 diyor hocam. O dediğiniz teoremle ilgili yukarıdaki soruda F0 eşittir 0, F1 eşittir 1 demiştik şurada.
Evet.
Şimdi kanıtlamak için. Ama burada hocam bundan bunu çıkarınca sadece 0'a 0 olması gerekmiyor mu?
Tabii tabii. Hı.
Ama yes diyor hocam. Doğru cevaba.
Hayır diyor ki is G continuous? Yes, it is continuous because f is continuous, x is continuous. The difference of two continuous functions are continuous. Is continuous.
Sıfırla
It's
1
about
arasında
continuity.
continuous diyor hocam. Sıfırla 1 arasında continuous diyor.
Of course, it's gonna say 0 to 1. Why? Because look, f is continuous on 0 to 1, and x is continuous on 0 to 1,
Ha,
and your difference is gonna be continuous on 0 to 1.
o zaman şu önemli değil. Şu.
No, it is important because if this function that you're subtracting from f if it is not continuous, then you cannot say that. But x is a continuous function because it's a polynomial, right? X is a polynomial.
Tamam anladım.
So it
Teşekkür
is
ederim.
continuous. So differences of two continuous functions is continuous.
Son olarak şu var hocam. Başka sorum yok. Bu aynı şey hocam. Deminkinin aynısı. X yerine
Bakayım.
C koyduğumuzda diyor.
Should I look at the last one? Sorry, I missed this. Can you repeat again? Okay. Solve for f of x in the equation and evaluate at c using the value determined by g of
FCC ise C eksi C'den 0 olması gerekmiyor mu hocam cevap?
Of course, g is 0. No problem. Solve for f of x it says solve for f. So what is f? F is g plus x. Okay?
Tamam.
And evaluate at c using the value determined for g of c. Let's see. Evaluate yeah. Okay, first of all, we are going to isolate f of x because that's what it says. F of x is equal to g plus x. You can write it there. G plus x. Okay, write g plus. Okay, g plus. G of x plus. Not c. G of x plus x is f. X is f.
Hocam,
Evaluate.
ben böleceğim. Çok özür dilerim de ben de Batuhan'la beraber aynı soruda yapamadım abi. Ve ben Batuhan'dan daha da az anlamadım. Ben bu sorunun çözülmesini rica etsem sıkıntı olur mu?
Yes, it's no problem. We can do that. Okay. This is intermediate value theorem. We have to discuss the intermediate value theorem. Okay. So I'm going to repeat what the intermediate value theorem says, and from there we are going to use intermediate value theorem to solve such a question. Okay.
Tamam
so
hocam.
Let's do that. This is number what? Do you remember question number?
Teacher, yes. I remember. It's homework 3 and question 9.
Homework 3, question 9. Okay.
Yes.
Let's do that. So can you write it in the chat because I have to first open chat question number and the section number, etc. Homework number.
Teacher, I can't write anything on chat. I'm not in
Okay,
register.
so let me write it for all of us. Okay, homework 3, question 9. Okay, question 9. Okay. And any other questions you guys may have?
I have one more. Hocam,
Go ahead.
sorulardan bir tane daha sorum var.
Emir, you tell me the numbers and I'm gonna write it in here.
Hocam, benim bir homework 2'de 21. soruda şeye baktım, example sorulara baktım ama soruyu anlamadım. Yani soruyu yaptım ama hani eksik bir şeyler var. Bir de homework 3'te question 4'te böyle küçük bir yer sormam gerek. Çünkü sizin videonuzu izledim. O sizin videonuzda siz bir şey yapmışsınız. Example soruda da aynısını yapıyor ama neden yaptığımızı anlayamadım ben.
Okay, sure. We should look at it. Okay, we can do that. Okay, let's start with these guys, and then if you had more, then we can go through more. Okay, so let me open up the intermediate value theorem. Just give me a couple minutes. Okay, I'm sharing the screen now.
Teacher, are we gonna do new chapter?
Actually,
Or-
I already recorded. I'm going to upload. I had classes all day, so I wasn't able to have time. I didn't have time to upload them. Section 3.1 and 3.2 will be included in the quiz. I'm not going to include 3, 4, 5. Just the 2 sections. That's enough. And I'm going to also complete recording 3, 4, 5 this week as well. But you're not going to be responsible in the quiz, okay? And tomorrow we are going to have, again, class. We can solve questions. If you are done with your questions, then I'm going to lecture.
Okay, teacher. Thank you.
Thank you very much. Yes, Mohammed Alit.
Teacher, about the exam, we will do it on the paper or on the word?
Yeah, the quiz you're going to do like you do homework. So you're going to do on MyLab, plus you're going to write it down with your handwriting, and you're going to write it rigorously, the solutions, explanations. I don't want just the answers. Some students did the homework just giving the answers. It's not enough. You don't get a point at all. If you write down just the answers, this is not writing the work. You're not writing your work. You're just giving the answer like in high school. It's not accepted. So you're going to write explicitly the solutions on a piece of paper and submit on MyLab or LMS, preferably not MyLab, I'm sorry, Teams or LMS, preferably Teams. Okay. I will write, after this class, I will write the detailed information about quiz. I will send it to you guys, okay? The sections, for example, 2.3, which is precise definition of limits, are not included in the quiz because we didn't cover. It's not included. And I'm going to explicitly write which sections are included, etc. Okay, so where's my page? Okay, so the intermediate value theorem says for continuous functions, it's for continuous functions only. So there are 2 requirements. I mean, how many requirements? Okay, 2 requirements, yeah. If has to be a continuous function on a closed and bounded interval, like a to b, like that, and y0 is a value between f of a and f of b, then you can find a c that goes to y0. That's what intermediate value theorem says. Because of the strength of continuity, you can find a c that's going to go to y0. If it's not continuous, you cannot find such a c. That's what the intermediate value theorem says. Let's go back to the question in our homework. Let's see. Where is it? This was homework 3, question 9, right? Just a sec. Okay. I have to get in again.
Hocam bir şey sorabilir miyim? Benim homework içinde 15 soru var ama sizde 20 soru gözüküyor.
No, it's not a homework 3 actually that you had seen. It is some other homework, I think. I was using that screen in the morning. It was open, so I don't think we are there yet, okay? I have to sign in again. The page that you have seen is not the correct one now.
Okay, teacher, sorry.
Just give me a little bit time. I thought it would be okay, but I have to sign out and sign in again. Okay. All right. But thanks for your attention. It's important that you are paying attention. Okay. Okay. So let's look at homework 3 and question 9, you said, right? Okay. Okay, let's go through that. So it says, suppose that a function f is continuous on 0. We know f of x is between 0 to 1, like f of a to f of b, if you remember. In this case, f of 0, you can consider like that. Or at least there is f of x is between 0 to 1 for every x in 0 to 1. Show that there must exist a number, okay, c, on 0 to 1 such that f of c is equal to c is called a fixed point of f. This is the fixed point theorem, actually. There's a theorem under this expression, actually. They are stating the theorem as a question. So in which scenario is the proof trivial? The proof is going to be trivial if f of 0 is 1 or f of 1 is equal to 0. F of 0 is 1 and f of 1 is equal to 0. F of 0 is 0 or f of 1 is equal to 1. Okay? So what is the answer for that? Okay, let's see. For A and B almost the same, right? Except zeros and ones are different. Okay? When we compare, okay, if you want to apply this directly, the rule, the intermediate value theorem says f of, okay, if you open this up, okay, just one sec. Sorry, I have an interruption here. I'm sorry. I'll be back in 1 minute. Okay, I'm back with you. Sorry for the for this break. So I am back with you. Okay, so if you look at this intermediate value theorem, it says if we have like if y0 is what? Y0 is between f of a and f of b, right? If there's y0 is between the two, then there is c that's going to go to y0. Let's imitate this, like consider this a is 0, consider this b is 1, and then consider f of a is 0, f of b is 1. All right, consider that. If this is the case, then we can immediately use, and c is between the two, right? Because c is between 0 to 1, then instead of y0, consider c, okay? Because c is between 0 and 1. I'm going to write this actually on a piece of paper, on the graphic tablet, graphic tablet, so that you can see. Just give me 1 sec. If I can find the pen. Okay. I would need a couple minutes too because it's in the other room. For some reason, I left it there. Just give me 2 minutes. Okay, so we are going to open up this new page. Okay, this is section 3. Okay, let me write that. Section 3, page 1. Okay, and this is homework 3, problem 9. Okay. Okay, here, I want to draw that. Okay, what does the mean value theorem says? So let's say, so this is 0, 1, and this is 0, 1. And then C is between 0, 1, right? If f of 0 was 0, and f of 1 would be 1, since C is here, okay, intermediate value theorem says this is y0 that they are talking in intermediate value theorem. By intermediate value theorem, we would say, by intermediate value theorem, this is the abbreviation, intermediate value theorem, okay? By intermediate value theorem, we would say there is okay, we would okay, we had to show that though. Yeah, I shouldn't put C. I should put just, first of all, arbitrary, then I have to show it that's C, right? So I am gonna call it, I have to call it something else first, okay? By intermediate value theorem, there is an A, okay? There is an A in 0 to 1 such that f of A would go to C. But they are saying f of C is equal to C, right? So we need to show that actually that A is going to be actually C, okay? But what they are saying is in which situation then you can say this is true. Okay, let's go there. Okay, if f of 0 is 1 and f of 1 is 0, the other way around, okay? Okay, what I could say, let's see. B is going to be the answer in this case because it's not the other way around, but let's see, f of 0 is 1, 0, f of 1 is 1. Okay, yeah, there's going to be a fixed point. The proof is actually taking f of x is equal to x, taking the g. Let's check that answer. Okay, yeah. Okay, so this is not going to be true. Why is that? F of 0 is equal to 0, f of 1, yeah, we did that. Let's see. Okay, just a sec. Let's see, why is that trivial though? F of 0, I'm thinking. It's increasing. Yeah, it's going up. Okay, let me make sense about this just a little bit. Just now, I'm going to get back to this, but the proof is actually here. Okay, maybe it's going to make it clear here. Okay, let's see. Let F0 is equal to A. Now we are going to step by step go to the proof. Okay, just leave this a little bit behind. Just first question. Let's go through the proof here. Let F0 is equal to A and F1 is equal to B. Okay. If the scenario above is excluded from consideration, what can safely be assumed about the values of A and B? Okay, these are the positive values, right? Let's see. Of A and B. F of 0 is going to be A. We are not going to think about this, I guess. Let's see. A cannot be less than 0 though. Okay, let me see. It's not clear. A greater than 1, B is less than 0, greater than, okay, A is less than 0, B is greater than 1. This is not really clear because why? First of all, it says in the question, it says f of x is between 0 and 1, right? F is never ever taking negative values. So you cannot really assume that A is negative, so A cannot happen. And this can be okay, and this can be okay. A is less than 1, B is greater than 0. Let's see. Interesting. Okay, let me think about this because it's getting okay. No. Let me choose. Okay, just a sec. This is a fixed point theorem. This one, I don't know what it is saying. If the scenario above is excluded, which is this scenario, okay, this is not even clear though. Look, f of 0 is 0, then it's going to be increasing. Okay, it's going up. Yeah, okay, I think the first one, let's get back to the first one, because if we don't get to the first one, then this is not going to make any sense. So in the first one, I think the solution is C. The reason is, look, the function f is between 0 and 1. We would consider f is taking values 0 and 1. In other words, f is increasing. If you assume C, look, f of 0 is 0 means there are going to be some values bigger than 0, because since f is between 0 and 1. Okay, this is, if we have that, then it's going to be decreasing. It's still going to be okay though.
Hocam tam tersi de olamaz mı?
Evet, burada bir hata var işte. Ben de burada takıldım kaldım. Ya çünkü A or C are similar though. Okay, so there is a little bit mistake going on here. Let me think about this and come back to you later. Okay, the rest it's clear. Let's click this for now. This is not going to be right probably. Okay. Okay. I got the right answer. Since f of 0 is not 0 and f of x is between 0 and 1, f of 0 is, let's see, A is greater than 0, B is less than 1. Let's f of 0 is not 0 and f of x is between 0 and 1. F of 0 is not 0. F of x is
yukarıda o zaman niye öyle diyor hocam?
Evet, ikisinde bir sıkıntı vardı, o yüzden ben de anlamaya çalışıyorum şimdi hani sıkıntı ne, ama bundan sonrası için the rest of the problem actual solution is like that. You are going to create a new function g, f of x is equal to x, and then it's going to be easier to continue, but this part I'm not really sure. Yeah, these two parts I'm not sure, but I'm going to try to understand what this is saying. Doesn't make sense. Okay, let's continue and get to this, okay? Define g, you are defining a new g, f of x is equal to x. is G continuous on 0 to 1? That's true. Why is that? Because f is continuous. X is a polynomial, it's continuous. So we are going to say it is continuous on the 0, 1. This is okay. Okay. And yeah, it's just explaining this as well. H of x, since both f and h of x are continuous over 0, 1, their difference, f of x minus h of x, is also continuous over 0, 1. Okay, let's continue to the other. Use the inequalities for the values a and b. To find new equalities limiting the values g of 0 and g of 1, choose the correct answer below. Okay, so at 0, g of 0 is going to be what? G of 0, f of 0 minus, is going to be f of 0. And g of 1, yeah, let me think about this question, because I think what they are trying to do is they are trying to give you the proof, but the way they start, it's not really clear. Sometimes the questions and the answers that they, let me make this clear during the break, and I'm going to explain it to you, right? Let's leave this a little bit. I'm going to just write this as a, it's an arbitrary. I got the
Hocam
right
bir
answer.
şey diyebilir miyim?
Evet, tabii ki, tabii
F
ki.
of 0 yukarıda 0 diyor ama aşağıda da 0 alamıyoruz.
Evet, evet, evet. Ben bir problemi biraz düşüneyim. Çünkü şimdi when they are trying to give a proof, ya bazen proofları böyle basamak basamak yaptıkları zaman yeterince ifadeleri net olmadığı için ya da ne bileyim şey olabiliyor. Yani anlaşılmayabiliyor. Ben ona bir bakayım, ondan sonra size bunu anlatacağım. Bunda bir şey yok aslında. Çok önemli bir teorem. This is an important theorem actually. But they are trying to give you, let you go through the step, go through the proof step by step. Let me think about this. Okay, I'll get back with you on this later. Okay, I'm gonna consider this in the break. Okay, let's do another example. Let's see. What is next? There was another question.
Last question, teacher.
Last question. Let's go through that. Last question in homework 3, right? Okay. 31. Yes. Let's say yes. Last question. Let's
15.
go. 15 mi? Okay. Let's go in there. Okay, very good. Okay, let's do that. Okay, actually I did this today in the morning with other students. We can go through the steps that I did. These are the answers, but I'm going to explain it to you how we did. It's in the video as well. Okay, for this question, first of all, we just talk about the domain. What is the domain? The domain is where the denominator is not 0, right? Everything that's not going to make the denominator 0. So if we solve x cubed minus 27, the only bad problem is 3. So the domain is obviously is going to be from negative infinity to 3 union 3 to infinity. When you're writing your answers, please use the things that appear down here, which I did actually when I was doing in the morning. So therefore, I cannot do anything right now, I don't think. And the range, for the range, we have to be careful. See, what it is saying is, in order to find the asymptotes and the ranges, use various limits. So it is giving you a hint. It says use the limits. And in the morning, actually, with other students, we did that, and I'm going to show you the pages here. It's, I think, before this. Not that, maybe. There's that. Okay, this one. Okay. So what you're doing is you want to find the vertical asymptote and horizontal asymptote. Before I get to that, I want to show you the picture. Okay. First, you have to see the picture. I used the Wolfram Alpha for you to see it. Okay. I wrote plot x cubed over x cubed minus 27. And when you drew it, okay, this is not very clear, but this is best because we zoom out and we see the whole picture. In the first one, it's zoomed in between negative 2.5 and 3.2. This is not very useful as much, but this is, at least for our case, it's not useful. I want you, do you see this plus that I'm showing right now, that I'm moving. Do you see this plus that's moving?
Yes, we
Okay.
can see it.
Okay. So this plus actually is showing the asymptotes. Look at that. We have an asymptote at 1, y is equal to 1, which is the horizontal asymptote. And we have a vertical asymptote, which is at 3, which x is equal to 3. So in the picture, you can see it very well. But how would you do it without the picture in front of you? Because in the test, maybe you won't be able to see it, right? You won't be able to have the Wolfram alpha in front of you to see it, to find it. Even if you do it by Wolfram alpha, I mean, you can check your work with Wolfram alpha, but you have to show your work. But how would you show your work? You have to use the limits when you're talking about the asymptotes. Okay, let's get back to the page. So in order to, for the asymptotes, we have vertical asymptote, horizontal asymptote, and oblique asymptotes. Here, we are going to start with the vertical asymptote. For vertical asymptote, we look at the denominator of the function. We know that 3 is a problem in the denominator. So this, the point that makes the denominator 0 is a candidate for a vertical asymptote. How are we going to make sure that it is really a vertical asymptote? We have to take the limit. Okay, so I'm going to just separate these two. So here, what did we do? We just take the limit as x approaches to 3 from the right. For vertical asymptote, just look at the one-sided limits. One-sided limits. Don't look at the two-sided limits. Okay, just any one of the one-sided limit is okay. If you look at the one-sided limit, I just chose it to be plus from the right. You could choose from the left. That's no problem. And then, so since x, okay, let me draw a picture here. Okay, we are, okay, our 3 here is, 3 is here, okay? We are approaching from the right. So the points here like 3.0001, let's say. Okay, if you cube it, if you cube this number, it's going to be bigger than 27. So here, this one, we make sure that it's a positive number that's getting close to positive number. Okay, that's getting close to 0. Okay, close to 0. Okay, maybe I should write 0 here. Okay, and since that's the case, okay, it's going to make the denominator 0. So we know the answer is either plus or minus infinity, but by checking this, we make sure that it's a plus infinity. Okay, finding this answer is also important. Since vertical asymptotes can be found after you take the limit, you get plus infinity or minus infinity at that point, all right? Which we did, okay? So this supports that x is equal to 3 is a vertical asymptote. Is this clear? Any questions on this?
No.
Okay. Next, we are going to do the horizontal asymptote. For the horizontal asymptote, we have to look at, pardon, what happens in the tails. In the tails means when x approaches to plus infinity and minus infinity, how does the function behave? Okay, so we look at the limit as x approaches to plus infinity. And how do we do that? We factor out x cubed, like I did here. Factor out x cubed here, factor out x cubed. You have in parentheses 1 minus 27 over x cubed here. And then simplify the x cubes, because I have x cubed here, x cubed here. And then I know that 27 over x cubed goes to 0 as x approaches to infinity, right? That's going to go to 0. And I have on top, I have 1. In the bottom, I have 1 minus 0. 1 over 1 is going to give me 1. So this is actually y is equal to 1. Okay? Because it's a y value. So therefore, I said that y is equal to 1 is a horizontal asymptote. Okay. Okay. Next, so we looked at, we found this after we looked at the limit as x approaches to infinity. How about if we approach x when x approaches to negative infinity. In other words, it's on the left tail. We call them tails. Okay, we want to look at the behavior of the function as x approaches to infinity on both sides. I mean, as x approaches to plus infinity, what happens? And as x approaches to negative infinity, what happens? What's the behavior of the function? We want to see that. Okay, so we are going to do the same steps here, and you're going to get 1 again. So this is going to say y is equal to 1 is a horizontal asymptote 2. Why did I do this twice? Why did I get this y is equal to 1 twice? Do I have to do that? Yes, I have to.
Yes.
Because sometimes when you look at the right tail, you may get a different horizontal asymptote than if you look at the left tail. Okay, we have to check them both. Okay, so we checked them both, and we got these two. Let's go back to the let's go back to the Wolfram alpha. Look at the look at when x approaches to plus infinity. Look, we have this y is equal to 1 horizontal asymptote, and similarly, as if you go towards the end, left end, as x approaches to negative infinity, this approaches to 1 again. Y is equal to 1. So we have the horizontal asymptote 1, y is equal to 1. Don't write 1, just write y is equal to 1. Okay, and for the horizontal asymptote, don't write 1 again, 3 again, 3 as well, right? X is equal to 3, otherwise it doesn't make sense. Okay, in the quiz, please make sure that you are careful about that. So my answers are like that. So what's the range then? So the range, as you would see, there is a problem at y is equal to 1. It is never ever equal to 1. But other than that, it takes everything else, the value. Okay, so we are going to say, and in page 6, I guess I wrote that. No, I didn't write that. Okay, what's the range? Maybe I write that here. We can easily write that the range is going to be everything except the 1. I think we write it on MyLab. Let's go back to it. Yeah, the range is everything except 1. Okay. In the quiz, actually, you can use Wolfram Alpha. You are allowed to use that to check your work, but you should show your work. Okay, like I did here. Of course, I went to Wolfram Alpha, I drew the graph, but at the same time, I proved it. I proved that horizontal asymptote is this, vertical asymptote is this. So you are allowed to use Wolfram Alpha during quiz, okay? All right.
Hocam iki tane range, yani 2 tane horizontal asymptotumuz olsaydı orada 4 adet blok olacaktı. Kümesi içerisinde.
That's right. I mean, for the range, you are talking about the range, are you?
Yes, sure.
You would have actually 3 intervals like that. One interval, union, another interval, union, another interval. If you had 2 different horizontal asymptotes, that's what you're saying, right?
Yes, thank you.
Okay. Just give me 1 sec. I have my little one here. I have to just look at him just 1 sec. Okay, I'm back with you. Let's see, any other questions? Homework 3, question 4. Let's do that. Homework 3, question 4. Homework 3, question 4. Homework 3, question 4. Yeah, let's do that. Anybody has any questions in there, like the previous one? If not, then let's start with that. Emir, you had some, so I'm going to do from the beginning, right? Let me do this from the beginning. Even if you have a little question, maybe some other students may see the solution as well.
Hocam.
Yeah.
Hocam 2 saattir konuşuyorum, sesim gelmiyor. Ben hocam bu soruyu yaptım ben aslında da size anlatsam hani nereye anlamadığımı anlarsınız mutlaka.
Yeah, go ahead.
Şimdi hocam kotanjantı çevirip yukarıya ters yani bu sinüs ve kotanjantları çeviriyoruz ya.
Yeah.
Orada bir yerde şey yapmışız hocam. Hani bu sinüs teta bölü teta 1'e eşit ya direkt.
That's right.
Orada sinüs teta bölü teta yazmışız. O bölü teta'nın nereden geldiğini anlayamadım ben bir türlü.
No, okay. Let's get back to that page, maybe. I can show it to you on there. Okay, let's do that like that. Yeah, that's better.
Siz çözmüştünüz bunu.
That.
Siz çözmüştünüz bunu. Videodan
Evet,
baktım
evet.
ama o teta nereden geldi anlamadım bir türlü
Okay,
ben.
I will try to find it if I didn't erase them actually. Here, right? This one, is it? No, not this one. No,
Evet,
not that
hocam.
one. Not this one either. Or we can write it from the beginning, no problem. It is the trick, actually. I mean, it's not a big trick, actually. Let me find it.
Sanki yukarıda da bir teta olup birbirini götürmeli diye düşündüm. Çünkü hani
Hocam,
yoktan geliyor ya.
Götürüyor. 1 bölü x'e u diyoruz orada. Ben öyle bir şey hatırlıyorum.
I just didn't want to rewrite it, so I'm trying to find it. Just give me a couple minutes. I think I must have it somewhere here. Otherwise, I'm going to write it quickly. No problem. It's very easy. Okay, we have a little bit more. Okay, let's see. It's this one, right? Yeah, it is this one, right? Can you see it? Can you hear me?
Yes, we can see you, but I think this is not the one. I think this is not the one, teacher.
But it's similar, isn't it? Okay, there's a tangent theta.
No. Sizin gösterdiğiniz soruda tanımsız çıkıyor ama bu sorunun cevabı var hocam. Yani
bir dakika, o zaman yapalım. No, it's the same thing though. It's look, this is no, it's not finished. This is not finished. It's just I just said that, but we continue. Look, do you see that? Okay, this is the same question except instead of 6, we have 2. It's the same type of question. All right?
Teacher, you opened the question just earlier.
Okay, I will do that.
1 çarpı 1 çarpı 1 çarpı 6'lıydı o soru. Yani sayılar değişiyor ya zaten sürekli. Açtınız az önce o çalışma sayfalarından bir tanesini, sonra değiştirdiniz.
But this is homework 3 question 4. Do you see it in the picture? I mean in the screen?
Yes.
Yeah, this is the.
Yes. Hocam bundan bahsetmiyorum. Bu soru zaten o soruda sizin hani o OneNote'larınız var ya, More uygulama.
Evet.
Orada az önce açtınız, sonra değiştirdiniz. Soruda böyle 1 çarpı 1 çarpı 1 çarpı 6 vardı. O soruydu çok büyük ihtimalle.
Tamam, siz you stop me, okay, when I get there. Okay, just a sec. I'm gonna go backwards because it should be backwards. You stop me.
Hocam görünürde yok o soru ya. Ama yani az önce o gösterdiniz çünkü mesela benim sorumda da 1 çarpı 1 çarpı 21'li mesela, anladınız mı? O soruydu büyük ihtimalle. O yüzden onu dedim.
Siz bana soruyu verin. Aklınızdaki soru neyse onu verin bence. Çünkü hani homework 3 question 4 bu. Yani başka da bilmiyorum.
Emir soruyu söylesene kanka.
Soruyu yazarsanız ya da söylerseniz.
Ben yazamıyorum hocam ya. Eklenmemiş herhalde.
O zaman söyleyeceksiniz bana.
Hocam ben bir dakika hemen söyleyeyim size. Şuradan açayım bir. Tamam. Hocam şimdi benim çözdüğüm soru tanjant teta bölü teta kare çarpı kot 21 teta.
Okay. Ha, 21 mi?
Aynen. Ben bunu açtım hocam. Sinüs teta bölü kosinüs teta çarpı sinüs 20 teta bölü kosinüs 21 teta.
Evet.
Ondan sonra sinüsleri tek başına bıraktım. Kosinüsleri tek başına bıraktım. Zaten teta sıfıra gidiyor ya, o yüzden kosinüsler direkt 1 oluyor. Sonra sinüslerin altına, hani bu sizin öğrettiğiniz bir teorem vardı. Yani sinüs teta bölü
Okay.
teta.
Let me
ya.
do that. I understand you. Okay. Let me do that so that other students are also not confused. Okay. I understand you now.
Okay,
Okay.
thank
Let's do that. Let's do that for today's class. Okay. This is section. Okay. Let me copy this because I have to keep it. Okay. Let's do that. Okay. This is good. This is page 2. And then this is, here is the question. Example, I'm going to write it. Okay. So limit, okay, of this, which is, I'm going to exactly write what you said. Tangent theta over, in parentheses, theta squared. Let's use x, okay? X squared instead of theta, because theta is going to be more confusing. X squared times cosine, cotangent 21x, that's it. All right, so I'm going to do this exactly the same way. The trick is the same, by the way. All right, as x goes to what? X goes to 0, right? As x goes to 0, I'm going to make this larger for you, okay? Just a sec, so that you can see it better. All right, so this is it. And I'm going to move this a little bit here. Come on. That doesn't go. Okay. So what the trick is, I'm going to continue with this now. Okay. All right. So for this one, limit is x goes to 0. Okay. As you said, everything is correct. You just write it as sine x, cosine x. Okay, times 1 over x squared. I'm going to write everything separately. And this is going to be cosine, what? 21x. Okay, and I'm going to take the sine 21x above because it's right. Do you see that, Emir?
Yes, I can see it.
Okay, good. And then, all right, and then from here, what I'm going to do, so first of all, I want to do one more thing here. Look, I want to do this too so that you can see it better. Okay, so I'm going to write 1 over x and 1 over x. How is that? Okay, then I'm going to use my red color. Where's my red color? How can I? Okay. All right. I want you to see this now. And I want you to, before I do, I need to do one more.
Şimdi oldu. Siz o 1 bölü x'leri ayırdınız ya. Ben oradaki aşağıdaki x kareyi unuttuydum. Şimdi oldu. Çok teşekkür ederim.
Okay, yeah. Let me finish for other students, okay?
Okay.
I'm gonna take this 1 over x to the other side to make it easier for us to see. Okay, so this is gonna be 1 over x here. However, I have a trick here, which is I'm gonna multiply this with 21. Okay, here 21 too. Okay, this is the trick, and you would see, and I'm gonna use my red color again, and I'm gonna circle it. Look, circle these two. Okay, now this is gonna go to 1, and this is gonna go to 1, and then my answer is gonna be, it's equal to limit as x goes, and also let me do more, and I'm going to use the green color, and observe that cosine x goes to 1 as x goes to 0, and cosine 21x goes to 1 as x goes to 0. Thank God. Okay, so the answer is going to be, all right, so the answer is going to be just 1. Is it 1? No, 1 times 21. 1 times 21. So the answer is 21, right? That's it. Thanks for asking this question, and that's how you should do it. If you guys have a question, let me know. Otherwise, we are going to move to the next question. Okay, Shehmuz, no problem. And homework 221. Homework 221. Homework 221. Let's go to any other questions in homework 3? Actually, we did these ticked ones in morning class, so you can also check it out. The video that I'm gonna put in 1 hour or so. I mean, after our class. Okay, I'm gonna go to homework 2. Where is it? Homework 2. It's gonna open up. Homework 2. Homework 221. Homework 221. Okay. All right. Oh, it's similar. Okay. So let me write this. Do you want me to do it? You guys, if you want me to do it, it's
Hocam
similar.
bunu ben sormuştum da az önceki 4. soruyu çözdükten sonra bir kendim bakıp dönsem daha iyi olur sanki.
Yes, okay, because it's similar. So
Aynen o yüzden.
Thank you very
Çok
much.
teşekkür ederim hocam.
No problem. So any other questions you may have? Shastinem said homework 2 question 3. Let's do that. Homework 2 question 3. Let's do that. Homework 2 question 3. Homework 2 question 3. Yeah. Okay. Okay, what does it say? The figure to the right shows the distance time graph for a muscle car accelerating from a standstill. So a car is standing still. Just one sec, I heard something from my little one. I'm so sorry. Okay, sorry about that. He's eating something, and I was scared that he's gonna be choking or something. Okay, so I had to check up on him. Anyways, so I'm back with you. Thank God. Everything is fine. Okay, so all right. So here in homework 2, muscle car is at the beginning. It is standing still. And this graph shows, use the information in the figure to answer parts A and B. The table below lists the coordinates of the points. Estimate the slopes of the sequence PQ1, PQ2, PQ3, PQ4. Determine the order from least to the greatest of the slopes, okay. Determine the correct units for these slopes. The slope of secant PQ1 is approximately. Okay, PQ1, we have to enlarge it. Let's enlarge it a little bit. PQ1, where's our P? P is up here. Let's see whether we can enlarge it more. P is here. Q1 is here. What is P? P is actually 20 to 650. So I'm going to write it down, 20 to 650. This is P. What is Q1? I have to estimate it, okay? So these are like going five units each, okay? These on the T-axis. And on the Y-axis, they go like, how many pieces it is divided? 1, 2, 3, 4, 5, 6. I have to count. 7, 8, 9, 10, 11, 12, 13. Is 325 divided by 13. Let's divide it by 13. 2 times 26, and I have 65, 6 left. 65 5 times. So each interval here is 25 units, and on the y-axis. Okay. So Q1 is approximately. I have to write what Q1 is. I have to find it out. So Q1 is actually the T coordinate. So these are 5 pieces. So it is like 5, 6, right? 6. So the X coordinate is 6. And the y coordinate is, I have to, okay, how many? 1, 2, 3, 4, 5. 5 intervals here. So 5 times 25 is 125. So I found approximately Q1, and I found exactly P, which is 22,650. So the slope is going to be, I have to calculate it because they are asking the result. So I'm going to go back to our graphic tablet. So I'm going to go there. So I'm going to calculate that. Okay. Okay, let me copy. Okay, just a sec. Okay, let's open up a new page. Okay, page 3. This is homework 2, question what? Question something. 21, I guess. Okay. All right. And then from here, okay, I found that P is equal to what? I mean, let's write P capital. P is 22,650. Okay, let's close that. Okay, I have to use that. And Q1, okay, and Q1, Q is capital. Q1 is what? 6 to 125. Okay, and what is the slope of the secant line? Slope of the secant line PQ1. PQ1. 1. So this is going to be just a ratio. Okay, it's going to be y1 minus y2, x1 over x1 minus x2. So 650 minus 125 divided by 20. Okay, let's write it in brackets. 20 minus 6. Okay, what is this approximately? 525 over 14. So what is 525 over 14? I'm going to go back to Wolfram Alpha, and I'm going to ask it to calculate. Okay, find, I'm going to say, find, okay, find this. Let's see if it's going to give me the answer. It should. It says 75 over 2. It doesn't, what is that? Why didn't it give me that? It should give me that though. Yeah, 75 over 2 is approximately what? I want approximately, maybe approximately, I should say, approximate this. 2 p's. Let's see whether it's going to understand that. Decimal approximate 35.5, 37.5. Okay. Let's go back to where we left off. Okay, this is going to be 37.5. It's equal to that. Okay, let's go to the answers. Go to the answers. Let's see, 37.5. Does it make sense? It says incorrect. It didn't like that. Why not? And we did that. See, sometimes it doesn't like. Was it wrong division? No. Probably no. I think we did maybe more than 6 here. Maybe bigger than that. I don't know. But what we did is right. Okay. Let's make it 38 then. Let's make it 38. Like that. Yeah. Did we do the division wrong, or maybe estimation's not right? Okay. So here, in order this to be 39, 125 is not right. 125. So this is 1, 2, 3, 4, 5. It should be right. 5 times 25 is what? 125, isn't it? I think it's right. 125 is right. 6 is right. Maybe this is more than 6, maybe, right? 5
Teacher,
plus 1.
can
Maybe
I
it's
say
more than 6. Yeah, go ahead.
Teacher, actually, it's written on the table upside.
What does it say?
Point and coordinates.
Oh, okay. I didn't. Okay, yeah, that's true. This is right. Okay, Q1. Of course, I have to use that. I ignored that. Sorry about that. It's my bad. I thought that I should get it here. Why didn't you stop me? I just missed that table. So we have to use this. That's why it's otherwise it's wrong. Okay, we are going to do that as well. So let me get to it and correct it. 6.4, 121. Okay, 125 even it's not right. Okay. 6.4, 121. 6.4, 121. I got interruptions here, so sometimes I do such mistakes when I have interruptions here. 121, and this is 6.4. And then, so I have to do this on, and then it's going to be 39, right? Let's write the answer right away. Okay, just erase that. Okay, so that's easy. So you're going to do the Q2 similarly. I think the rest should be okay. Okay, so Q2, you're going to P Q2, you're going to take this 2, and then use the secant line slope. And okay, so this is this may just I'm gonna just make this up. I'm gonna say 26. It doesn't matter. We have the correct answer. Okay, we want to skip to the other page. Okay, but it doesn't allow me to go to the other page. I wanna. Okay, go ahead. I don't want the answer. Go. Okay, so okay. Oh, another one. I want to get to the B. What's the question B? Anyways, is the question B clear for you guys? I mean, should I get to that? So I'm gonna similarly. I'm gonna just. Okay, come on, get to the next page. Okay. Oh, one more. Okay, let's make it maybe 60 this time. I just made it up. Okay. All right, just a sec. Okay. Come on. I was close this time. Okay, what is the order of the slopes for the secant? So we are going to order it. I'm just going to, you can easily look at the numbers that you found and you can order them. It's easy. I'm going to just say, okay. You can easily order them, right? So I don't think it's a hard question. So I want to skip to the next question. That's fine. I just made it up. What's the appropriate unit for these slopes? Let's decide on the units. So we are talking about the distance time graph for a muscle car accelerating from standstill. What's a muscle car? Anybody knows?
Teacher, actually, it's right on the graph.
Okay. So meter per second directly you can say that. Yeah, that's good. No problem. Okay, that's true. Estimate the speed at P. The speed at point P is approximately. How would you estimate that? You have to look at the slope at that point. So we are going to go to the point P. Since we created all these slopes.
Answer is PQ4.
Huh? What's that?
Answer is equals to PQ4.
The speed you mean?
PQ4, it's written in the before answer.
That's right, but I think what they want you to do is you already listed PQ1, PQ2, PQ3, PQ4, and you're going to look at these numbers where they get close to, and of course PQ4 is going to be the closest. And you can easily compute that and get an approximate value to it. Yeah, the idea is just to make sure that you have a table of numbers, because this is the limit idea. They are trying to tell you that since we don't have the function explicitly written, they just want you to build a table of slopes, look at the values and look where they get close to. And if you just look at the PQ4, it could be okay, but it's always good to look at the whole list that you ordered. That's why they ask you to order them, okay, from smaller to the highest, smallest to the highest, that least to the greatest, okay. And let's look at the, yeah, they don't give you the numbers. Okay, the numbers were up here, right? Let's look at those numbers. Oh, the correct answers. So PQ1 was 39, PQ2 is 43, PQ3 is 51, PQ4 is 51. So they are getting close to this. Okay, let's see.
51.
Okay, 51. Because these are the correct answers. The answer is 51. They are taking you to the answer. I mean, they are leading you to the answer. So it's 51 meter per second. Okay. And second square, second, yeah, no problem. Not second square, I'm sorry. Okay, next question is this. We did that in one of the classes, I guess. Yeah. Anyways, that's good enough. Let's go back to. Okay, let's go back to the questions. You may have more. Yeah, it is done. All right. Did we solve any questions in homework? Homework 3, I solved questions in the morning. You can refer to that, but you can still ask me questions if you have any questions here. This is, let me see. This is homework 2. So we didn't solve too many questions in homework 2.
Teacher, someone wrote something.
Okay, let's check it out. Same homework 2, question 2. Okay, let's get to that. Beshta is asking that. Same homework, which is homework 2 and question 2. Okay, let's get to that. I think we did that in previous classes. This one. Okay, this is a good question. Actually, we did that in the morning, actually. This is a good question because this is, you can easily solve this by using the topic in section 3.1, okay, which I recorded videos for them. And let me do that video as well. Look, they are asking you to find the slope of the curve at the given point P and an equation of the tangent line at P. And the function is given, y is equal to -3, -4x squared. And the point that you have the tangent line at is given as 3 to -39. So we are going to find the slope. We are going to find the equation of the tangent line. Now, I'm going to get to the in the morning's class lecture because we have the solution, but I want to talk to you about that too. Let me see. I think this was it. Let's see. Yeah. Let me see whether I have anything in the front. Let's see. Actually, in the morning, one question asked me that why do we use these secant lines to get to the tangent line? And this is where I explained it to her. And you can actually watch the video. I think it was a good discussion. So I recommend you to listen to it. And then after that, we answered this question, and it was really good because when we were talking about the secant line, this made a lot of sense. So, I mean, let me do that. Okay, the question is, let me write an example in the front. This was, this is homework 2, question 2, yeah? Let's write it in here. Y is equal to -3, -4x squared, and point is this. Find the slope and tangent line equation at that point. Okay, so how do we do that? Solution. We first write the rate of change quotient. I mean, I call it rate of change quotient, but you can call it the quotient, I mean, quotient formula. This is the quotient formula. And then we want to just look at this quotient, and then we are going to take a limit of that. This quotient actually is what, in terms of secant lines? It is the slope of the secant line at the point 3 as you vary h. H is going to get close to 0 when you're taking the limit. As you vary h, you're going to find several secant lines. These secant lines, the limit of the slope of these secant lines is going to give you the slope of the tangent line. That's what we discussed in the morning. So here's at P. This is the point P, and then we have Q1, Q2, Q3. We use these points Q that are approaching P to form our secant lines, okay? And then we look at the slopes of these guys and take the limit of the slopes like we did in the previous question. And the limit that we get is going to give us the slope of the tangent line. That's the same idea. But 3.1, in chapter 3.1, we give this a name. We don't call it, we give a formal name, which is a derivative. Actually, taking the limit of this quotient is going to be called as the derivative of f at 3, okay? It's the definition. Okay, so let's find the quotient first. The quotient is f of 3 plus h minus f of 3. Let's call this f, okay? This is f function over h. So I'm going to use that function, negative 3, negative 4x squared, and plug in 3 plus h for it. Negative 3, negative 4, 3 plus h squared minus f of 3. F of 3 is going to be plug in plug in 3 in x, and you get negative 39. Let's plug it in again. 3 squared is 9. 9 times 4 is 36. Negative 3 minus 36 is going to give you negative 39. So I have this expression for the quotient. Next, what I'm going to do, I'm going to expand it. So I'm going to expand this squared expression. So negative 3 minus 4 and square that. 3 squared is 9. 3 plus h times 2 is 6h plus h squared, close the parentheses, plus minus 39 gives you plus 39. Now this 39 and this 4 times 9 is negative 36 and negative 3 is negative 39. So I have negative 39 on here and positive 39 on down here. So they cancel each other. And what is left is negative 4 times 6h squared, 6h, which is negative 24h, minus negative 4h squared over h. So I have this quotient simplified this much, but I can simplify further. So I take out h, because h is common factor here. I factor out, actually negative h, I factor out. So there's this negative here in the front, if you don't see it. Okay? Factored out negative h, and what is left is 24 plus 4h, okay? And these h's, h here and negative h's here and h here, we can cancel them, we can simplify them, and I got negative 1 on top times this expression, okay? Then we found that the quotient this is mq p, okay? This expression, I call it m, but that's what I mean, it's the slope of the secant line for an arbitrary h. Okay, as we vary h, it's going to be a different secant line slope. Okay, and we take the limit of that. So we call this expression is just slope of the secant line, and I'm taking the limit as h approaches to 0, negative 24 minus negative 4h, and I call it the slope of the tangent line. Slope of the tangent line is shown as m. Then we take the limit, as I said, it's limit of this expression. We got negative 24. Maybe I should move this a little bit if I can. No, I can't. Okay, let's see now. Let me erase that if I can. Okay, let me erase that and write it nicer. Okay, this is the m. Okay, but the quotient is negative 24 minus 4h. Okay, so maybe I should circle it like that because and then I have this m, we take the limit, and we found the limit as negative 24. Okay, as h goes to 0. The tangent line equation, so I want to say something here. What we found as negative 24 is actually the derivative of f at 3. This is chapter 3.1. Okay? Derivative of f is just a formal name to it. whenever we talk about the derivative of f at 3, we can also understand it to be slope of the tangent line at 3. Or we can also understand it like this, slope of the graph at 3, okay? They are all the same. Okay. And we are actually repeating, we are also talking about 3.1. So chapter 3 is really not extraordinary. It is just formalizing, like making everything formal of the things that we learned so far. Okay, it's not very difficult chapter. They are asking about the tangent line equation at the point 3 to negative 39. You know how to write it. Line equation y minus y naught is equal to m times x minus x naught. I just put in all the values here and I get that. In MyLab, they want the answer to be simplified like this one. So I have to simplify the answer, but in your handwriting, you can leave it like this. I mean, it doesn't, I don't care. But for MyLab, it may not accept this one. It may accept this one, okay? You would want to do that like this, okay? This is the MyLab version. I'm gonna write it, okay? This is MyLab version. In the handout, the handwritten one, you can write it like this. It's okay for me. Either one is fine, but because of the MyLab, you have to simplify it. Handwritten work, this is okay. Okay. All right, we did that. What is next? Do you have Beshta? Is that clear for you? Can you respond, Beshta? Okay, good, wonderful.
Teacher.
Okay, any other questions? What time is it? It's 4. We started at 2:30, so we still have time. We can do a little bit more.
Teacher, can I ask a question?
Of course.
Hocam orada x artı h yaptık fonksiyona, yani fonksiyonun x yerine x artı h yazdık. Bunun sebebi fonksiyon üzerinde p'ye çok yakın yeni bir nokta oluşturmamız mı? Ya aynı geçen sorudaki gibi.
You mean this expression you're talking, the one that I'm circling in below? Is that what you're saying?
Evet.
Okay. So they're asking. Let me tell it in Turkish first, and then I'm going to explain it in English. Şimdi burada x yerine tabii ki 3 yazdık. Çünkü 3 noktasında bizim şey istiyor. Slope'unu istiyor, tangent line'ını istiyor. Sorunuzu tam anladım bilmiyorum, anladın mı? Ya bu bir formül, zaten kullandığımız bir formül. Derivatifin tanımında kullanılan bir formül zaten. Ondan sonra 3.1'in şeylerinin lecture videosunu bugün izlerseniz orada çok açık olacak sizin için. Mutlaka izleyin. Biz hani biraz 3.1'i aslında 2'nin ikinci chapter'da soruluyor bu. İkinci chapter'da tablo yapıyorsunuz. Çünkü limitini almak falan, hani limitini alabiliyorsanız alıyorsunuz, şu expression alabilirsiniz. Üçüncü chapter'da artık diyor ki buna bir isim verelim, derivatif diyelim diyor. Yani bilemiyorum, sorunuza yanıtladım mı? Bilemedim.
Hocam sadece şeye sordum. Bu 3 artı h dedik. Bu h'ı eklememizin sebebi P'ye çok yakın bir nokta olan Q noktası diyelim ona. Onu bulabilmek adına ya da ifade edebilmek adına. Tamam.
Kesinlikle. O 3'ün sağında solunda noktalar koyuyoruz. Ondan sonra o Q'ları oluşturuyoruz. Dediğiniz doğru. Ondan sonra bu H, işte H'e değişik değerler verdikçe biz o Q1, Q2, Q3'ler vardı ya. Onlar oluşuyor. Evet, çok güzel. Evet, teşekkür ederim. What he was saying is, Oğuzhan was saying, the reason we have this 3 plus h because we are trying to find, 3 plus h is going to take us to the points Q1, Q2, Q3, right? And then we combine this point P and Q1 and point P and Q2, and we get these secant lines. Actually, this expression that you have here, for a different h, you get a different Q. And this is the expression of the slope of the secant line for each different h. Okay? So that he was saying, and he needed a confirmation, and I confirmed it. What he's thinking is right. Okay. Any other questions on this one? Okay. Okay, let me see. Any other questions I may? Let's go back to chapter 3. I mean, homework 3, I should say. In chapter 3, maybe we can solve some problems too. For example, 3.2, let's solve a problem. We didn't solve a problem before in morning's class. Let's open it up. Nobody asked a question, so I'm gonna solve it. We can solve one more question, and I'm gonna let you go.
Aslında ben bir şey sorabilirim istersen.
Of course, of course.
Şu continuity'de bir fonksiyonun sürekli olması için 3 tane şart vardı ya.
That's right.
Bu 3 şartın bir daha bir açıklayabilir misiniz?
Of course. Now, what he's asking is, Batuhan asking is, I'm going to tell you, I'm going to give you some information, some examples as well. Let's do that here. Okay. Let me open up a new page. That's a good question. Okay. I can create some examples instead of going through MyLab's question. Okay, there's a continuity test. Let me write this in let me type this actually. Typing is better. It doesn't, okay, let's see. Okay, continuity test. Okay, one, it says f, okay, let's make it little f, f of, or capital F, doesn't matter, f of a exists. What does it mean? F of a is going to have a finite value. Finite value. That's what it means. And then the limit is x approaches to a, okay, exists. All right, and then say L, say this limit is L. I'll give it a name. The third one says f of a has to be equal to this limit value, which is L. Okay, so f of a has to agree with the limit as x approaches to that point A. That's what it says. What can I say? I can give you some written examples. Okay, example. All right, so okay, let's give this a value 4. Let's give this a value 2, and then let's say this is 5. Okay, this is the function y is equal to f of x. The reason that this function is not continuous at 5, first of all, this checks f of 5 is 4. F of 5 is 4. This, I mean, let me make this bigger though, because otherwise, can you see this handwriting, the typed one? Is this clear, or should I make it bigger? Can you see it?
It's clear.
Okay.
That's clear.
Okay, then I'm not going to enlarge it. Okay, f of 5 is equal to 4. So this it passes the first part of the test. The second part of the test says, how about the limit as x approaches to 5? Okay, we are gonna let me use the draw feature. If you approach from the right, the limit is this much, which is 4. If you approach from the left, the limit is this much, which is 2. Okay? Do they agree? Not at all. So they don't agree. So the second one fails. The limit doesn't exist. Right and left limit, they don't agree. So this fails. So of course, obviously this fails as well. So it didn't pass the test. Okay, 2 of the 3 are wrong. I mean, it's not wrong, but not satisfied. So this is not a continuous function at 5. Okay, we are going to say f of x is not is not continuous at 5. Continuous at 5. Okay.
Hocam,
Hı hı.
5'e yaklaşırken şimdi başka bir yerden soruyorum. O
Hı hı.
yukarıdaki uzun çizgiyi 5'ten devam ettirebilir misiniz bir saniye? Yok, aynen devam ettirin. İçini doldurmadan. Sağa doğru çizgi hocam.
Şunu devam ettireyim mi? Şöyle mi?
Evet. İçini doldurmadık.
Okey. Öyle
Şimdi
yapayım. Bir saniye öyle bir örnek yapayım size. Anladım ne demek istediğinizi.
Sağdan, hayır şimdi başka bir şey soracağım.
Okey, tamam.
Sağdan limitimiz 2, soldan limitimiz 2. 5'te. 5'in normal limiti de 2 değil mi? Yani 5 limite sahip oluyor.
Tabii limiti var ama bu sefer şey olmuyor. Üçüncüsü de onu da yapayım ben size. Evet. Üçüncü condition satisfy olmuyor bu seferde. Yeah, the first and second condition is okay in that case, but the third condition doesn't is not satisfied. Okay? So let me make it clear for you. So this is another situation as you are pointing out. So the graph is like this, and then like this. And then let's say it is, let me see. Let's say it is defined here, okay? So this is, let's say, 1, and this is 1 from the left and right. It is 1, that's good. So that means 1 is satisfied, which is, let's say this is, let's give this 5 again. And let's say this is 10. So first is okay. F of 5 is 10. It is finite. This is okay. The second is okay. Limit L is 1. But the third one fails. L is not 10. 1 is not equal to 10. Is this what you're saying?
Evet, teşekkür ederim.
Okay, and also we have the infinite limits as well. We can give an example too. When you have such a thing, we have, I wanted to tell you guys about 3 types of discontinuity. Discontinuities. One, jump discontinuity. Okay. 2, removable discontinuity. And the third one is infinite discontinuity. So we have the jump discontinuity, removable discontinuity. We talked about the 2, but we didn't call it removable. 2 is important. We did this. We extend a function to make it continuous. Okay, I'm gonna just start with 2. Removable, and even we solved some questions about remove the discontinuity at that point. It said, for example, here is the 1. I'm gonna give you that, okay, the same question, but it's not gonna fill this in. Okay, I'm gonna leave it blank. All right, and then okay, all right. Let's say this is 12. Let's say this is 5 again. It doesn't matter, 5, 6, 5. It doesn't matter in a number. Let's say f is this much. Okay, and then obviously f is not continuous at 5. Okay, f is not continuous at 5. Not continuous at 5. But this is a removable discontinuity. What does it mean? You can redefine the function removable discontinuity. Why? Removable discontinuity, because you can redefine it. You can extend this function to make it a continuous function. Okay, we can extend this function. We can extend this function, extend f of x to make it a continuous function, to make it a continuous function. Because of that, it is removable. You can remove the discontinuity. You can make it continuous by defining it a new function. Let me see. I want to get down here. And how would you do that? You're going to fill this in. Okay, you're going to say, you're going to define a new function g. Okay, here's how you're going to do it. I'm going to write it in green here. Okay, so your extended function is called g. You're going to say, whenever x is not 5, it is f. Call it like f. It's going to be f. But whenever x is 5, you define it as 12. Okay, now g is continuous. G is the extended continuous function, extended function of f. Okay, so g is an extension of continuous extension. Continuous extension of f. It is almost f, but except one point. Extension of f of x. Okay, it's continuous for sure. In the picture, how are we going to do that? The graph is going to change to, we are going to just fill this in. Now it's continuous. Do you see that? The green one plus f is the g. Okay, now it is g. I'm going to put an arrow here. Put an arrow, and now it becomes g with the blue and the green. Okay. For jump discontinuity, you cannot remove it. Like, I'm going to give you an example to the jump. Okay, for jump discontinuity, you have it like this. Look, like a step function. Here is one, and here is another pair. Like, is there any way you fill in the gap so that it's continuous? No, no way, because it's a big jump here. Okay, here's a jump. You cannot make it continuous at all. I mean, so this is a jump discontinuity. And infinite discontinuity is going to be the infinite. Look, do you remember the butterfly? Here's the butterfly function. Okay,
yes, it's continuous, just
everywhere. It's
zero.
continuous everywhere except 0, right? This is an infinite discontinuity. There's this, because of this infinite value, it's 0. There's no way you can make it. You can remove the discontinuity. I mean, it's just the infinite discontinuity here. Okay, because of the 0 point. Butterfly is an example to this. Okay, these are what we know of. All right. Any other things? I think time is up. We have 2 minutes left. If you don't have any other questions, we can stop here, and we are going to do more questions tomorrow. We are going to solve more before the quiz, and I'm going to keep recording, and you are going to watch the recordings for the lectures, and yeah, we'll do that like this. But solving problems is important. That's why I'm spending a lot of time for you guys to spend. I mean, you can watch other sections recordings when we do the like solving problems, like virtual classes we do with other sections. You should also watch, because I'm solving different problems in each section, kind of different. Sometimes they match, but sometimes they don't. So I would strongly recommend you guys to watch other sections recordings as well, especially the Wednesday classes, or maybe makeup classes like this. Okay,
Teacher,
go ahead.
which one?
What's that?
Which one?
Emir, söyle Emir.
Hocam, ben şimdi zaten Section 1 öğrencisiyim de bizim bu quizle ilgili bana bir mail gelmedi. Section 1'a herhalde şey gelmedi. Mail gelmedi. Section 2 ve Section 3'e.
Yollamadım. Yollayacağım şimdi. Dersten sonra yollayacağım.
Hocam son bir şey ben de sorayım.
Nasıl gireceğiz hocam o quizlere? Yani nasıl olacak? Bir bilgilendirme yapabilir misiniz?
Okay, I can tell you. Quizzes are going to be like homework sessions, but see, I'm assigning homework, but it is for like a couple of weeks, right? For the quiz, you're going to have only 3 hours. Okay, 2 hours on MyLab. Okay, the MyLab part is going to last 2 hours. And when you're doing the MyLab, you should also start writing it down. Okay, and then I give you extra 1 hour just to upload it. Okay, so make sure that in 2 hours you finish the handwritten one as well as the screen one on MyLab, like you're doing the homework. Okay, in the homework you have an extended time. For a quiz, you don't have that extended time. You have just only 2 hours on MyLab, plus 1 hour to upload it to Teams or LMS. I would recommend you to upload it to Teams. It's easier for me to to follow. It's very easy to open it up and take a look. For LMS, I have to download it, I have to open it up, and I have to save it somewhere, blah, blah, blah. So it takes longer.
Teacher, we are responsible for just 3.1 and 3.2, right?
3.1, 3.2, and chapter 1.
Chapter 1? Okay.
Of course, yeah. We did chapter 1, we did chapter 2, and we chapter 3.1 and 3.2. That's all to it. No more. And 2.3 is not included in chapter 2, which is we didn't cover 2.3.
Atlamıştınız hocam orayı.
Yeah. Any other questions? Okay, if you don't have any other questions, take good care of yourselves. Okay, be careful when you go out. Yeah, study hard for all your classes, especially math class. Okay. Ask me.
See you.
See you. Take good care. Bye bye.
See you.
Bye bye.